let's look at this number 5. For this question, also limits, right? There's a limits will be equals to limit approach to 0, parenthesis, square root 3 plus x minus square root 3 over x. Of course, remember the previous question we just talked about, use the decimals, find the value of x equals 0, and then find the value of x before 0, like negative 0.9999, and like the number, like I just write down here, okay? So you may do the similar way I showed you before. For example, x equals 0, right? And then you can, since x approaches 0, you may from the left side go. That means from 0, 9, or 0.999, but negative though, huh? Oh, no, my bad here. So it should be what? For this way, should be negative 0.1 or negative 0.01, like that, closer to this side. And this side will be what? From 0.1 or 0.001, like that, closing this one. So use decimals, you will see both sides, the number will approach some value. That will be the, we call it as the limits when x approaches 0. Of course, they must be equal. The left limits or the right limits must be equal. So that's one way. But for this one, I prefer to show you another way, okay? Because there are many different ways to deal with the same question. For this one, we try to time the conjugate of this, all right? So what we're gonna do is this. We time both numerator and denominator by square root 3 plus x plus square root 3. And this one also square root x, 3 plus x plus root 3. We know that when we time from elementary math, we know that both numerator and denominator, if you time by the same number, there is no problem with that. You just change the format of the fraction. You're not changing the value of the fraction. Just like we did before, like for example, you have 1/2, right? I time by 2 here, time by 2 here, I will got 2 over 4. 2 over 4, 1 over 2. They are same fraction, same value, just different format. That's no problem, right? So that's why I can do this. I time both sides by, both numerator and denominator by the same number or expression. Be careful here. Here is minus. So I time its conjugate. We call it as conjugate. This one, the one I time it here is called conjugate of the original one here. Why I'm doing that? Because we can see the limit 1x approach to 0. Of course, you can use the formula. This one times this one, 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 right? That's for you, huh? We call it the 4EO. You know that, what's the meaning of 4EO, huh? First F is the first term. O is called outer. I is inner. And then L is the last, okay? So this one is from basic algebra 1, okay? Of course, you can also use the formula we call it as what? A squared minus b squared equals what? A plus b and a minus b, like this. So a plus b, a minus b equals this one. So we can directly use the formula that's even faster, okay? So if I apply that formula to here, we will get square root 3 plus x. Oh, hold on. The pen, always sometimes something wrong with the pen. Sorry. Okay, let's write it one more time. Yeah. So limit x approach to 0. We have the first one squared will be what? Square and the square root of this one, we will get what? 3 plus x. Okay. And the minus square root of 3 here, we will get what? Just 3. over the bottom one, we just have x times by what? Square root 3 plus x plus root 3, like this. You know why we need time this one and this on the top? The reason for that is this, because at the beginning, if you look at the original question here, right, you directly plug in x equals 0, that means what? Denominator equals 0, that's no good. And also numerator, when you plug in x here is 0, square root 3 minus square root 3, also 0. So this kind of type of limits belongs to what? Belongs to, as one mentioned, it's like a 0 over 0 type. That's indeterminate. So we have to use our strategies to cancel the one, make the denominator equal 0, okay? That's why we time the conjugate of this. When we do this, we will get limit x approach to 0. Top part 3 cancels, so you have x over x times by parentheses square root 3 plus x plus square root 3, okay, like this. Now, when we got this one, you see here, you see I changed the color here. So you see here, this x will be canceled. After you cancel, you have limits x approach to 0. You have top is 1 over this x cancel already, no more. So you're gonna have only what? Square root 3 plus x and the plus square root 3. Now, when you got this, I write it here, okay? Space is limited. So I'm going to plug in the x equals 0 in. I will get 1 over square root 3 plus 0 plus square root 3. So continue. 1 over square root 3 plus square root 3. This means 1 square root 3 plus 1 square root 3. You got 2 square root 3. But we need to simplify because mathematicians always like the denominator with no radical sign. So we got time this one by square root 3. We time this one by square root 3. You will get square root 3 over this one equals 3. Time by 2 is 6. So this is the answer. Okay? Let's go back to what we did so far. We got the answer here. Just be careful. When you have the limits, when x approaches 0 or certain number limits, the function is not defined there. Means well, it's not continuous at that point. So you cannot simply plug in 0 for the x value in. So you have to do something. I did this method. This is normally used methods. So you can use the algebra. Of course, here we use the what? We call it as Fourier methods. I hope you can review this part. Yeah, every time when I explain one question, my way is like this. I show you how to do those. And then along each steps, there are several things related to your pre-calculus, algebra, geometry, and trig. I will pour it out for you and explain to you that you have the chance to quickly review and to see clearly how those basic algebra, geometry, or trig will be used for the calculus problem, okay? Along you doing those more drills, you will be better, all right? Thank you. And also, I hope you can give me advice or suggestions about how to improve the video quality. And also, like, if you have any questions, please let me know. Thank you very much. Bye-bye.